everybody. So we're going to continue to review. This way it can be used in, you can check all videos or you can check some videos, depends on what you need. For these questions, we're going to address a different set. As you see, we have, and we'll do the same style where, I'm not limiting the time. I'm not trying to make it shorter or longer. It depends. So the idea here is you've seen these, or if you haven't seen them, you will need to do more after the video. This way you have a better understanding of what's going on. But of course, if you've tried them and they're not clear, this should help the understanding of these concepts, because here we talk about, or I talk about some other details that may not be explained. For example, if you access a page on a textbook or something. But we'll do the best we can, but keep your mind open to these different scenarios, so you have a better understanding of what's going on. And think about this way: if you need to explain it to somebody else in the future, then if you have a better understanding now, it's, you can review it quickly and just explain it. If we're following only a pattern, then the pattern can lead us to some knowledge, but when things change, that's where we may run into a problem. Okay, these, you'll ask that we've done inequalities, for example, this, and now why are we working with this type of inequalities? Well, we graphed functions, we dealt with functions, and in some cases we're interested, for example, we are interested, let's say, let's just take this example. As you see, this function up to this point from the left, this side, it's above the x-axis, which means every y value you take here is going to be positive. But as it passes this point in the domain, the y values are negative, and they remain negative until it gets here, right? Then once it passes this point here towards the right, as it rises toward the right, this y values become positive again. So in some problems, we'll be interested, for example, where is the function positive? In another meaning, where it is above the x-axis, or where it is below the x-axis. So to write this down, so this is just, you can think about this as the line y equal x plus 1. So now we're not dealing with these basic function. We're dealing with maybe something bigger, a quadratic function, a polynomial, and of course this can be done for other functions. So the idea here, if you're asked for a function, let's say less than 0, then we mean below the x-axis, right? And if we're asked for, so maybe we'll clean this out. Maybe we'll leave that graph there. And so this is one fact that we need to keep in mind. And we'll add one thing to it before I do the positive, is a function less than 0, you see less than 0, means we're looking for where it is negative, right? Or the y value is negative. So two things, because we want to simplify the way we do these inequalities. And if we have the understanding, then we will be able to simplify that. So when I say function, this is a function. You know, if you remove it from that picture, you can think about it as f of x is x minus 6 times x minus 1. You FOIL it, you have x squared and this and that, right? So it is a function. So let's do the other one. If we say a function greater than 0, it means that we need above the x-axis. Above the x-axis, the y value is positive, right? So that's the first thing we need to understand before we solve, because this thing less than or greater than, it's going to be switched to the idea of positive or negative, right? Okay, so that's one thing we need to keep in mind. And this picture here, let's say if this is negative 2 and this is, let's say, 2, for example. So this grid here, it just says this part here. So to understand what's going on, so for example, this part, we're saying here that between negative 2 and 2, the function in this domain, it's below the x-axis, it's somewhere here. And whether it's open dot or closed dot, that has to do, just like with the previous information that we worked with, whether this is less than or equal or just less than. So if we have less than or we have greater than, we often or always use the open circle, unless we're talking about parentheses, right? Then that's another way. But for here, we're adopting these open and closed thing, or shaded circle there. Then it's this, or unless if you're using, then it's brackets. Okay, so this is the idea in general when we deal with this type of inequalities that are usually harder because they're just being solved without understanding what's going on. And then you do the sign chart and or something like that, and you try and you're like, okay, positive, positive, it's this. But what's happening? Well, this is what's happening. It's we're not graphing the whole thing, but we're targeting a certain, you can call it a property or a certain interest about the function. So let's look now at our example. We have x minus 1 and x minus 6 multiplied. That's a quadratic function. Less than 0, we're interested where it is negative. So this translates to negative, right? And one way to do that, and we'll do it for these examples. So this, the way we're going to pick here is we're going to need this to be in factored form. So you can call it, before you start, you need to need kind of a factored form. In this case it is, so that's good. Now we're going to do a step 1 to find something we call critical points or values. And step 2, we're going to find testing points. If we say points, we can say again points or values, right? So or values. And once we find them, these two steps will allow us to find where it is negative. Then the final step, we're going to answer the question. We're going to answer, and if there is a solution, then we're going to describe the solution either on the picture or with the interval notation, right? So let's work out this example here. We're going to split this here, this way. And we're going to continue here. So we'll call this continue question 14. So what are the critical values? The critical values are, we set as usual, they're pretty much the zeros. We set these as x minus 6 equals 0 and x minus 1 equals 0. So x equals 6 and x equals 1. So these are the critical values. If we put them on the number line, that will show us what the interval, or it will show us that the line is divided now to 3 intervals. All right. So you have one part, negative infinity to 1, and we have between 1 and 6, and we have 6 to infinity. So in order to know what's happening in these 3 parts, then we need the second step, which is testing values. We need to find out, we need to investigate. So we need to test it and find out, is it positive or negative there? So different people do this differently. Some will do x minus 1 and then x minus 6, and some will go for the whole thing. So let's first decide the testing points, and let's do that, for example, with the orange. The testing values, since I'm interested in this part, then I need to find the value from here, and it can be any value from negative infinity to 1, right? And keep in mind, we don't have or equal, so these probably we can do this way, which means they're excluded. So any value from there, let's say 0, right? And you can try 0 into the problem itself and for the function itself. So you can 0, as I mentioned, cancel, so it's just negative 6 times negative 1. And what's happening there, it's positive 6, but intentionally just to keep it so we understand what's going on. It's a positive 6, but we're interested whether it's positive or negative. So the answer here is positive, because if you try a different value, you'll find a different answer. However, it's going to be positive. All the values there, or the testing points there, will give you something that is positive. So between 1 and 6, you'll try 2. Let's say I'll try 3. So here I tried 0, and let's try 3. So 3 minus 6 and 3 minus 1, that's negative 3, and that's a 2. Again, that's a negative 5, negative 6, I mean. But we're not just making it small because I want to make this statement here negative, right? So let's do a 7 or an 8 or a 10 or 1,000. So as long as any, let's write it here somewhere we have space, any value n from 6 to infinity, which is this part here. All right, so we did these parts. So a 7, 7 minus 6, 7 minus 1, that's a 1, and it's a 6, so it's a positive. So we're interested for this statement here, less than 0, which means negative. And let's use, yeah, we haven't used green, so let's use green for now. Just say, it looks like this is what we are interested in, where it is negative, which means it's going to be between between 1 and 6. So between 1 and 6. And because, so maybe we'll clean this so it does not look confusing in the notes. if somebody's looking at the notes, will think maybe the question is less than or equal. So the question, since it's not or equal, we're not including 1 and 6, and we're gonna select in between. All right. So what does this mean? It means any x value that we're gonna select, we're gonna try it here, and it's gonna be negative. And the graph, it's happening below the x-axis here. All right. So if this question now asks, so maybe we do a different color, just for my purple. If this question is x minus 1 greater than 0, so if, right, what do? The method does not change. We check whether this is factors, so because we want to find the zeros. Factoring makes it easy to, with the zero product property, right? Then we find the critical values, which means those zeros there, and we have testing points, and we test and all that. So that's not going to change. Then you come to this picture here, then you find where it is, because here it's once a positive. Then now instead this box screen, it's going to be outside of it, this side and this side, which means these two intervals, negative infinity and 1, and 6 infinity, negative infinity and 1, and 6 and infinity, that's the 2. And we put a union for the 2. So the process is going to remain the same to find out what's going on with the function. Then we'll answer it based on the request, right? So for this next question here, as you see, graph the solution to the following inequality. So you do have, but something I didn't talk about here, because this is already set. So now we need to say, need the factors form, and we'll finish it with and. So to make this complete, and 0 on the right side, because having 0 on the right side makes the comparison easy, right? Because 0, if you have it, the left side of it is negative, the right side of it is positive. But if you pick, let's say, negative 8 right here, you see this is negative and this is negative, so you can compare. If it's less than, it's not easy to compare that way, but 0 is, it's makes it simple. All right, so what we will do to have this statement here is we need to, just like you did for a quadratic function or equation, you brought it to a standard form by having 0 on this side, right? So that's the same thing. So you've done it before, and now you do the same thing. So you add 8 to both sides. Now we have it. We have 0 on the right side. Then we need to see if this factors. The product is 8, so 8 and 1, 2 and 4, right? So the factors of 8 and 1. What else? We say 2 and 4, but we need a 6, so the 6 will come up from these two. 2 plus 2 plus 4 is 6, right? Yeah, we're doing a marathon of videos, so I think we'll make sure we'll go the same way and get it done. But I'll record other videos after this one. But if I say something and it's not correct, let me know. But I'm trying to correct this as I go to make sure we don't have any error there. So 2 times 4 is just 8, and 2 plus 4 is 6. So the factoring is correct. And once now, so we compare now 15 and 14. So they're the same question now, right? Except, so you can say now you have question 14. So if you did 14, now you have question 14. The only difference is or equal to 0 means these are closed and brackets on the numbers for this type of problem, right? So you set this to 0, you get -2, and you set this to 0, you get -4. And let's fill it up just to make sure we're showing this again, that we put them on the number line. Then we're gonna test each one or each interval, right? So let's do that with orange again. So from here, -4, you pick -5, -6, anything there to test. -2, -3. So if this is -2 and -3, doesn't mean you don't have a number. There is so many numbers there. You can pick a decimal. So if this is -2 and this is -3, it's -2.5, right? So there is always a number between two numbers, right? So you can find the number there. So -2 to infinity here. So you have -1, you have 0. So we can pick 0. It's easier. So let's try it here. We're comparing to 0. The question here is less than or equal 0, which means we're interested in negative again. So this is now like number 14. So -5 plus 2. We'll test it here. -5 plus 4. -3. -1. And that's negative times negative, that's a positive. So we just go for it. It's a positive 3. -3 plus 2. -3 plus 4. So -1. -3 plus 4 is 1. So it's negative. All right, so 2 and 4 for the 0 value. And that's 8. That's positive. So it looks like similarly to this example, now it's happening in the middle as well. And now just to show, so we'll use green again, just these other green. Let's do dark green to show that what we're interested in is happening here. So in this case, we're gonna say the solution. Let's see if we scroll down, if we have, yeah, so we have more space. So the solution here is between -4 and -2, and as you see, or equal, we have brackets on these numbers. And of course, if the question is about positive, then you will do or greater than or equal the -infinity to -4 bracket and bracket on -2 to infinity. But I think now it's kind of clear, and it's just a matter of trying, and you can always check your answer. These can be checked. So between -4 and -3, and we can try as well here and to see whether this is correct or not. So we have 2 more examples, and we'll finish this video and pick up on another one. So this is a polynomial. It's similar to the other examples. And we've done some other examples, and maybe we'll see them in other videos where, for example, this is 2 squared or something like that. So we need to just watch. We need to test. You should test all and not skip some. So if this is square, don't skip it, because some will say, since it's square, it's positive, it's not affecting this sign chart thing, whatever. No, just use the zeros. Go as I showed. If you're using this method, find the zeros. The zeros are 8. X minus 8 equals 0. That's 8. That's a 2. That's a negative 4, right? So negative 4 greater than or equal, so we can use these numbers in this type of problem. And a 2 and an 8, you know, and you do the same thing. So this is maybe an example I'll give you to try and explain the other ones. So we talked, it's factored, it's ready to go and to be tested after this. So you can take negative 5, you can take 1, 0, you can take 5, 4, whatever. You can take 9 and 10, and use your testing values just like we did, and all that stuff, and find the answers. So this one I'll say similarly to others that we did, and I'll write a note about the other one. So here I would say try like previous examples. So it's a similar example like 14. Doesn't matter, it's just you have more intervals to test. And we'll put a note here that if some reason you have something like this, right? One of them is squared. Don't skip. Just follow same process. That's one idea. So if I have, for example, x plus 1, you still have a 0 there as negative 1. The 0 is negative 1. It's just what the idea here is, you will use the understanding of a multiplicity that we talked about. Since this is square, then which is even, the multiplicity is even. So at negative 1, there is a touch, which means it's going to bounce back. So if it's positive, it's going to remain positive. And so it's important to keep that in mind and connect the multiplicity to this. And that's a different video when we deal with similar examples, but now we have these squares and we connect them to the multiplicity examples. But here what I want to mention is when we get something like this, often we confuse it with something like this. Is this 2? Is this negative 1 or 1? Sometimes it happens. Or this is 1. Now this is not 1. You know, we've done it before. This is x plus 1 and x minus 1, which is a difference of squares. So here you have 2 zeros, which is negative 1 and 1, right? So if this is x plus 5, you have negative 5. If this is x minus 3, then you have 3. So you have 4 zeros. In this case, you have 3 zeros, but one of them has a multiplicity of 2. So this is just as you do these other examples, to keep in mind that if you follow the same process, you're not going to miss it. And the other idea of of simplifying intervals. So I will talk about that when I do the video on this and that type of example, because I want to talk about it, and it's going to take maybe 10 minutes just to talk about this type of examples. But I want to keep it here simple to these type of examples where the multiplicity is still 1, and we make sure that we understand what it means. So this is a polynomial that it turns and all that. Then we're interested to where it is positive or equal to 0. All right, so last example for this video is a rational function that is less than 0. So don't forget, it's still a rational function. We just did some talk about them, and which is a separate video. And we graphed this, right? And we saw with the asymptotes and all that stuff, and you graph and you saw the pieces where they are and all that. So here it's same idea, less than 0. But I don't want to start it as a new problem because we already did this type of problems. So the only thing we're going to do different, it's the process is still going to be the same. The only thing that's going to be different is here, the domain, it needs to be, of course, defined. So this denominator or vertical asymptote dictates something there. So what I will do, this is an easy case to solve. So I'm going to make that the problem is actually this. This is probably harder to solve than the other one, because the other one, even if you miss the check, you're going to get it correct. This one, if you miss the check, you're going to miss the question. So before we start these and other functions, we should first state, well, we know by now that x cannot be 1. If x cannot be 1, you cannot come at the end and say, for example, right, something like this. This is not acceptable because included 1 or including 1 means x can be 1. So I'm trying to give you different ways so we understand really what's going on and why we make some decisions at the end. So before we start, the vertical asymptote is there because if x is 1, this denominator is 0. And if this denominator is 0, then you're dividing by 0, and this is undefined. And who wants undefined, right? Nobody. So we don't want undefined. If we don't want undefined, then x does not equal to 1. So we take everything except 1. So which means at the end, when we solve and do all this nice work, we shouldn't come at the end and contradict ourselves or contradict the statement and say, yep, bracket and all. So that's the important thing. That's why if we find that half of the students miss this problem, it's because of this part here, right? So, so this is to watch for, and as a common mistake. All right, so now let's solve. Since we already did that work there, we're not going to create a new work. We're just going to say, let's treat this as if it was negative x. And I'm not saying multiply, I'm just saying as if I have these two, like we did in the past. So, you know, negative 6 and x equals 6, and x minus 1 equal to 0, x equal 1, right? Since we already did this, let's just, it's already given. So we can just go ahead and use the previous knowledge on this one. 1 and 6. And we're going to test again, since we decided these are the critical values, right? We're going to go to step 2 to find or test it, or find the testing values and try them. So on the left side of -1 of 1, we have we have 0, right? On left side of we have 0, and we also have on the right side we have 2, and here we have, let's say, 8. So these are the points we're going to test. We're going to test them, of course, in the whole thing. You can do it in two places, which means 2 steps. You split it, you do the first one, second one, you find the numbers, you divide them, either way. So 0 means 6 divided by -1, which is -6, which is negative. -2 for 2 plus 6 and 2 minus 1, it's 4/1, which is positive. -8 plus 6/8 minus 1, that's -2/7, that's negative, right? So we go to the green. I think that's what we did previously. So we're interested in less than or equal 0, which means negative. Negative happens here, and it happens here. So -infinity to 1, this always takes that, so that's not a problem. And 6 to positive infinity. So now what are we going to do with these? Less than or equal, up to now, the examples is to anytime you have or equal. For inequalities, you use brackets, right? But now we have a conflict. A 6 doesn't have a conflict, but we talked about a 1 having a conflict, right? Because from the start, 1 cannot be, x cannot be 1. And we can't now say that's a 1. X can be 1. So that's going to be a contradiction. So we need to resolve this. And we've done this previously. So we've done in the past. We had problems where we made decisions. And I'll give you an example. When we found time to be positive and time to be negative, you solved it, quadratic formula, give you 2 answers. One is positive and one is negative. And you rejected the negative answer because time cannot be negative. So we've done stuff like this, right? Geometry question. Length and width. And let's say you solved it and you find the width is 2 and -3. And you rejected this because the width cannot be negative. And you took 2, and for example, it's 2 times 2 plus 1, whatever, and you found, for example, whatever relationship there, and you found the length is 5. So we've done, when we get some extraneous solutions, we found that, and some of them we call them extraneous solutions. When extraneous solutions, when we solve an equation, whatever you have, and at the end you find 2 answers, -1 and let's say 2. We can't now, the math worked pretty good at the end, and we find -1 and 2, and we say, okay, yeah, the solution is this solution set, -1 and 2. Well, we can do that because now -1, it makes the whole thing undefined, so it does not solve it. So math is about the process, the reasoning, the thinking, and the decision at the end. Whether we answer the problem itself, right? So because when we don't answer the problem, different things can happen. Either we create a new problem, or or now there is a problem that's not solved and there is a solution that we think it's a solution, but it's not. So the decision is there. We do these checks, and although this thing looks simple, but I can tell you that we've seen sometimes half of the students would miss it. And this is the reason. It's because there is a check that should be there. And of course, somebody's going to ask, but what do we do with these? What do we do with these or equal? Well, for the fraction, or equal means the numerator can equal to 0. So that's this equal here applies to the numerator. It does not apply to the whole thing. So that's one way to understand it. So the solution kind set here, or these two intervals, are the solution. -infinity to 1. 1 is excluded. Union 6 included to infinity. Or equal, the numerator can equal to 0. This is okay. So this is okay. The denominator, so maybe we'll come here, say, the denominator cannot equal to 0. This is okay. All right. So I hope this clarifies this thing. And the idea is still the same, since it's negative, means where it is below the x-axis. So if we graph this, since this is a review, if this is a teaching video, what I would do is I will graph the function and show you exactly that how the graph changes and where it is below the x-axis, where it's going to be in these intervals. All right. Thank you. If you have questions, let me know.